Hello and welcome to this lesson for OCR A-Level Physics, Module 6, Particles and Medical Physics, in the topic of electrical fields, looking at the concept of Coulomb's law. So if we've been successful and we've learnt in today's lesson, we should be able to define what the force experienced on charged objects when near other charged objects are, note the similarities and differences between the gravitational field of a point mass and the electrical field of a point charge, and then calculate and describe the electrical force experienced on charged objects in an electrical field. So we're going to be looking at the following parts of the OCR A-Level Physics specification, 6.2.2 Coulomb's law. Now, our understanding of electric fields took a long time to develop. Now, both gravitational fields and electrical fields follow the inverse square law when considering the force produced between the two objects. Now, this occurs as both gravitational fields and electrical fields work by the same underlying mechanism. We consider mass producing a gravitational field as a point mass, and the charges producing an electrical field as a point charge. Now, both field lines spread out as spheres, and this gives a 1 over r squared relationship due to the surface area formula of a sphere. So if we consider a point charge producing an electrical field, we can say that the greater the distance from the electrical charge, the larger the spherical electrical field. Now, this area is given by the equation 4 pi r squared, and this gives our inverse square relation. However, there are two major differences between gravitational fields and electric fields. Firstly, the field strength of each field, which is represented by different constants in the equation. And secondly, the electric field can be attractive or repulsive, represented by a positive or negative value, whilst the gravitational field can only be attractive. Now, in 1785, the French physicist Charles-Augustin de Coulomb published his first three reports of electricity and magnetism, where he stated the mathematical relationship between the electric force and the distance between objects. Now, he used a torsion balance to study the repulsion and attraction forces of charged particles and determined that the magnitude of the electrical force between two point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them, and he called this Coulomb's law. So Coulomb measured the electrostatic force between two electric charges. He defined opposite charges given an attractive force as given a negative value for the electrostatic force. This occurs as a positive times by a negative is equal to a negative. Also note, we also measure r, the separation of the charges, to be from one centre of mass to the other centre of mass. Now, Coulomb defines same charges which provide a repulsive force to give a positive value for the electrostatic force. This occurs as positive times by positive is a positive, and a negative times by a negative is equal to a positive. So Coulomb measured the electrostatic force between two charges, and he deduced that the magnitude of the force F between charges Q1 and Q2 is proportional to the product of Q1 and Q2, i.e. Q1 times Q2, but inversely proportional to the square of this distance r between them, and this forms the basis of Coulomb's law. So this means that our relationship between force and separation is F is equal to 1 over r squared. So this tells us that when the separation is doubled, the force exerted decreases by a factor of 4, 2 squared. Now, you must be able to state the relationships of Coulomb's law as well as state the mathematical equation. Now, so as we know, F is proportional to Q1, Q2 over r squared. Then Coulomb then deduced the constant of proportionality between the factors. Now, we can therefore say that our constant of proportionality is k, where k is equal to 1 over 4 pi epsilon 0, where epsilon 0 is the permittivity of free space, which is 8.85 times 10 to the minus 12 farads per meter. Now, this value can change depending on the material between the charged objects. At A level, it's assumed that there's air or vacuum between the objects. If there was a different medium between the charged objects, there would need to be a different constant used in the calculation. So therefore, we can now state Coulomb's law as F is equal to 1 over 4 pi epsilon 0 times by Q1 Q2 over r squared, or F is equal to Q1 Q2 over 4 pi epsilon 0 r squared. Now this equation calculates the electrostatic force between two objects due to their electric fields. It also will indicate that both charged objects will experience this force. So this force is the same force on each charge. Now each charged object may accelerate a different amount if they have different masses. As we know, acceleration is equal to the resultant force over the mass. Now, our Coulomb's law is very similar to Newton's law of gravitation. However, charge is used instead of mass, as charge produces the electrical field. In addition, a much larger constant is used in the equation, as the electric force is much larger than the gravitational force. However, it must be noted that Newton's law of gravitation and Coulomb's law are very, very similar. Now, for Coulomb's law to be accurate, three assumptions have to be made. Assumption 1. Objects are considered as point charges. The charged objects must not be touching, and they must also be stationary. So here is a summary of Coulomb's law. So let's now have a look at an example calculation using Coulomb's law. Find the force experienced by a free electron 2.83 mm from the centre of a 1 mm sphere carrying a charge of plus 0.510 microcoulombs. The charge of an electron is minus 1.60 times 10 to the minus 19 coulombs, and the mass of an electron is 9.11 times 10 to the minus 31 kilograms. So we firstly identify the force given between the two objects is calculated with Coulomb's law. F is equal to 1 over 4 pi epsilon 0 times by Q1 Q2 over R squared. We then identify our two charges and the separation between the two charges from the question. Now remember, the separation from the centres of masses is what is going to be our value of R, okay, not the surfaces of the object. So we then place these values into the Coulomb's law equation to say 1 over 4 pi epsilon 0 times by 0.51 times 10 to the minus 6 times by minus 1.60 times 10 to the minus 19 over 2.83 times 10 to the minus 3 all squared. Now, when you then calculate your force exerted, remember F is equal to minus 9.16 times 10 to the minus 11 newtons. Now please remember, in this question the R term is squared. People commonly forget to do this. Finally, you give your answer to the appropriate number of significant figures with the correct units, and you state whether the force experienced by an object is either attraction or repulsion. Now, because it's a negative value, it shows that our charges are attracting to each other. As I said before, do not forget to square your separation value. It's a common mistake in questions. And remember that both the free electron and the sphere are experiencing this charge. Now you can state if the force between the objects is attraction or repulsion by looking at the sign of the value. Now finally, you can investigate forces between the two charged metal spheres using Coulomb's law. Now the balls can be charged positively by touching each momentarily to the positive electrode of a high tension supply. Lowering one of the charged spheres down towards the other will produce a larger reading on the balance. Now this value on the balance can be used to determine the electric force exerted on either charged object. Now by measuring the separation between the charged objects, the total charge on the objects can then be calculated. However, when we're using this, the separation is measured from the centres of both objects. So to summarise what we've looked at in today's lesson, we know Coulomb's law, which is that the force between 2 point charges is equal to QQ over 4 pi epsilon 0 R squared. We've looked at the similarities and differences between the gravitational field of a point mass and the electrical field of a point charge, and then finally looked at the concept of electrical fields as being a number of forms of field giving rise to a force. So if we've been successful, and we've learnt in today's lesson, we can define what the force experienced on charged objects when near other charged objects is. We can note the similarities and differences between the gravitational field of a point mass and the electrical field of a point charge. And then finally, we can calculate and describe the electrical force experienced on charged objects in an electrical field. So thank you so much for watching this lesson, which is part of the Particles in Medical Physics module in OCR A-Level Physics in the topic of electrical fields and on the concept of Coulomb's law. Thank you so much and have a lovely day.